Students, welcome back to maths class on chapter matrices. In our last session, previous sessions, we were discussing the problems on algebra of matrices. Today, we shall consider some more problems on that concept. If A equals to we are given A matrix, comma, B equals to and C equals to then compute A plus B and B minus C. Also verify that A plus inside the bracket B minus C is equal to inside the bracket A plus B minus C. So in this question we are given three matrices. Each matrix is of order 3 cross 3. So using these three matrices, first we need to compute A plus B and B minus C, and later we need to verify this particular result. Okay. So first I will find out A plus B matrix. Okay. So in the place of A, I will write down A matrix plus in the place of B, we will write down B matrix How do we add two matrices? Two matrices are added by adding the corresponding elements. Already we are familiar with this concept, is it not? Okay. Let us add the corresponding elements. This is 1, 3, 4, 2, minus 1, 1, minus 3, plus 2, minus 1, 5 plus 4, 9, 0 plus 2, 2, 2 plus 5, 7, 1 plus 2, 3, minus 1 plus 0, minus 1, 1 plus 3, 4. This is our A plus B matrix. Okay. So we have computed A plus B matrix. Now we need to compute what? Matrix B minus C. So write down B matrix 3 minus 1 2 4 2 5 2 0 3. This is B minus C matrix 4 1 2 0 3 2 1 minus 2 3. How do we subtract two matrices? Two matrices are subtracted by subtracting the corresponding elements. While we add or while we subtract, we use the concept adding or subtracting the corresponding elements. Okay. So if it is plus 3. This is minus into plus, minus 4, plus 3 minus 4, it is minus 1. Here it is minus 1, this is minus 1. What do we get? Minus 2. This is plus 2, this is minus 2, 0. 4 minus 0, 4. 2 minus 3, minus 1. 5 minus 2, 3. 2 minus 1, 1. 0 minus into minus plus 2. Don't forget to consider the signs. Here it is 0, minus into minus plus 2. 3 minus 3, it is 0. So we have computed A plus B matrix as well as B minus C matrix. Now we need to verify this particular result. Verifying any result means we need to show that LHS is equal to RHS. So I will take left hand side. So A plus inside the bracket B minus C. So in the place of A, write down A matrix plus in the place of B minus C, you use the matrix which you have already found out. Okay. Again, you need not to compute B minus C. Already you have found out B minus C. Use that result here. So minus 1, minus 2, 0, 4, minus 1, 3, 1, 2, 0. So let us add these two matrices. Okay. So this is plus 1, this is plus into minus, minus 1, plus 1, minus 1, 0. This is plus 2, plus into minus, minus 2, which is 0, minus 3, plus 0, minus 3, 5 plus 4, it is 9, 0 plus into minus, minus 1, 2 plus 3, 5, 1 plus 1, 2, minus 1 plus 2, it is 1, 1 plus 0 is 1. This is our LHS. Okay. So now I will take RHS. So RHS is what? Inside the bracket A plus B, outside minus C. Already we have found out A plus B matrix. I will use it. So what is our A plus B matrix? It is 4, 1, minus 1, 9, 2, 7, 3, minus 1, 4. This is our A plus B matrix minus C matrix. 4, 1, 2, 0, 3, 2, 1, minus 2, 3. Okay. So now, I will write down RHS here. RHS is equal to, let us subtract these two matrices. This is plus 4, this is minus 4, which becomes 0. This is plus 1, this is minus 1, which is also 0. This is minus 1, minus 2, it becomes minus 3. Okay. So this is 9 minus 0. 9 minus 0 is 9. This is 2 minus into plus minus 3. 2 minus 3 is minus 1. 7 minus 2, 5. This is 3 minus 1, 2. See here, it is minus 1, minus into minus plus 2. Minus 1 plus 2 is plus 1. This is plus 4 minus 3, which is 1. So what do we observe? This RHS is equal to LHS. So I will call this as equation number 1 and this as equation number 2. I will write down the conclusion. From 1 and 2, LHS is equal to RHS. Okay. Next question. If A is equal to 0, minus tan alpha by 2, tan alpha by 2, 0. We are given A matrix and capital I is the identity matrix of order 2. Then show that I plus A is equal to I minus A into cos alpha minus sin alpha cos alpha. Always remember, dear students, from board examination point of view, on algebra matrices you get a 5-mark question. You need to practice each and every problem. Okay. So we are given A matrix and I is the identity matrix of order 2. What is identity matrix? Identity matrix is a square matrix whose all diagonal elements are equal to 1 or non-diagonal elements are equal to 0. He will not give you the elements present in I matrix. You must know its definition. Okay. So I will take left hand side. So what is left hand side? I plus A matrix. Okay. I is the identity matrix of order 2. So we write down I matrix as 1 0 0 1 plus A matrix is already given to us 0 minus tan alpha by 2 plus tan alpha by 2 0. Let us add these two matrices by adding the corresponding elements. 1 plus 0 is 1. This is 0 minus tan alpha by 2. We get minus tan alpha by 2. 0 plus tan alpha by 2 is tan alpha by 2. 1 plus 0 is 1. I will call it as equation number 1. So we have found out LHS. Now I will find out RHS and finally I will show that LHS and RHS gives the same matrix. Okay. Now, if you want to use RHS, first you need to have what? I minus A matrix. Observe right hand side. In right hand side, I minus A matrix must be multiplied with this entire matrix, isn't it? So first I will compute I minus A matrix separated. Then I will take right hand side. Okay. So I 1 0 0 1 minus A matrix 0 minus tan alpha by 2 tan alpha by 2 0. I identity matrix minus A is the given matrix. Okay. Let us subtract these two matrices now. 1 minus 0 is 1. 0 minus into minus plus tan alpha by 2. 0 minus tan alpha by 2 is minus tan alpha by 2. 1 minus 0 is 1. This is our I minus A matrix. Now I will take right hand side. So what is right hand side? I minus A into cos alpha minus sin alpha cos alpha. Already we have found out I minus A matrix, which I will use here now. This is 1 tan alpha by 2 minus tan alpha by 2 1. This is our I minus A matrix into cos alpha minus sin alpha into cos alpha. Now let us multiply these two matrices. How do we multiply two matrices? Two matrices are multiplied by multiplying the corresponding elements. Is it? No. When we multiply two matrices, we use row column multiplication concept. You need to remember this point. When we add or subtract the corresponding elements, but when we multiply two matrices, we use row column multiplication concept. Okay. To write down A11 of this product matrix, we need to multiply elements of first row with the corresponding elements of first column and add the products. I will repeat my sentence. To write down A11 of product matrix, we need to multiply elements of first row with the corresponding elements of first column and add the products. So what do we get? First row, first column. 1 into cos alpha, tan alpha by 2 into sin alpha. We must add the products, so I use plus sign. Okay. First row, first column. Corresponding elements are multiplied and added. Products are added. Next. First row, second column. 1 into minus sin alpha is minus sin alpha plus tan alpha by 2 into cos alpha. First row, second column. Next. Second row, first column. Minus tan alpha by 2 into cos alpha plus 1 into sin alpha is sin alpha. Second row, first column, minus tan alpha by 2 cos alpha plus 1 into sin alpha is sin alpha. Second row, second column, multiply the corresponding elements and add the products. Minus into minus plus. This is tan alpha by 2 into sin alpha plus cos alpha. Okay. So now I need to go on simplifying each term till I am going to get this LHS matrix, right? Okay. See how do we simplify it further? This is cos alpha plus tan alpha by 2 can be written as sin alpha by 2 upon cos alpha by 2. We know that tan theta is equal to sin theta divided by cos theta. So tan alpha by 2 will become what? Sin alpha by 2 upon cos alpha by 2 into sin alpha. Okay. So already you know this formula. What is that? Tan theta is nothing but sin theta upon cos theta. Is it not? In the place of theta, we are having alpha by 2. So tan alpha by 2 will become what? Sin alpha by 2 upon cos alpha by 2. In each term of the matrix where there is tan alpha by 2, write it as sin alpha by 2 divided by cos alpha by 2. Is that clear? Okay. So I will write down here LHS because finally I need to conclude that LHS is equal to RHS by comparing them. For reference I am keeping LHS here. So how to simplify the terms further? Yes, we will take LCM. If there is nothing at the denominator, we always take it as 1. So what will be the LCM of 1 and cos alpha by 2? It is cos alpha by 2. So for the first term, LCM is our cos alpha by 2. So if I take cos alpha by 2 as the LCM, so multiply these two terms now. So cos alpha into cos alpha by 2 plus sin alpha by 2 into sin alpha. On taking cos alpha by 2 as LCM, this becomes the numerator. In the second term also, we will take cos alpha by 2 as LCM. When you take cos alpha by 2 as LCM, minus sin alpha into cos alpha by 2 plus sin alpha by 2 into cos alpha. Right? Okay. Here also take LCM. What is LCM? Cos alpha by 2 is our LCM. So if I take cos alpha by 2 as LCM, numerator becomes minus sin alpha by 2 into cos alpha plus sin alpha into cos alpha by 2. Here also take cos alpha by 2 as LCM. So if I take cos alpha by 2 as LCM, numerator becomes sin alpha by 2 into sin alpha plus cos alpha into cos alpha by 2. Okay. Now let us simplify each term of the matrix. How do we simplify each term of the matrix? We will use trigonometric ratios of compound angle formulae. What is the cos of x plus y? Already we people have learned it at our PUC first year in trigonometric function chapter. Okay. What is cos of x plus y? It is cos x into cos y minus sin x into sin y. You need to know these formulae to simplify each numerator. So cos of x plus y is cos x cos y minus sin x sin y. What is cos of x minus y? It is cos x into cos y plus sin x into sin y. Okay. What is sin of x plus y? Sin of x plus y is a sin x cos y plus cos x sin y. What is sin of x minus y? This is sin x into cos y minus cos x into sin y. So we need to use these formulas. Which formulae these are? Trigonometric ratios of compound angle to simplify numerator. Okay. So denominator is our cos alpha by 2. Look at the numerator. Don't you think they are the terms of the formula cos of x minus y? Observe. Cos x cos y plus sin x sin y. So when I look at the terms present in the numerator, we come to know that they are the terms of the formula cos of x plus y, where x is our alpha, cos of x minus y, where x is our alpha, y is alpha by 2. So it becomes cos of x minus y. Cos of x is alpha, y is alpha by 2. Let us move to the second term. Look at the numerator very carefully. These are the terms of which formula? Observe all these four formulae, you will come to know. Maybe the terms not in the required position, but you need to understand. See, this is sin x cos y minus cos x sin y. If I arrange the terms properly, you will come to know this. Okay. So if I take this first and this as second, now I will come to know that it will become a formula sin x cos y minus cos x sin y. What is sin x cos y minus cos x sin y? Sin of x minus y. Sin of x is our alpha by 2 minus y is our alpha. You need to understand the terms properly. You need to choose x and y properly. See here, this becomes sin x cos y minus cos x sin y. So sin of, in the place of x we are having alpha by 2 minus in the place of y we are having alpha. Okay. So denominator is our cos alpha by 2 here also. Let us simplify the numerator. Again look at the terms. They are the terms of a formula. Which formula? Sin x cos y minus cos x sin y. Say, observe very carefully here. X is alpha, y is alpha by 2. Sin x cos y minus cos x sin y. Okay. So what is sin x cos y minus cos x sin y? This is sin of x minus y. Let us take the fourth term, that is a to 2. Cos alpha by 2 is our LCM. Look at the numerator again. Yes, this is cos x cos y plus sin x sin y. Observe very carefully. Terms are not in the standard position. You need to understand the terms clearly. Cos x cos y plus sin x sin y. What is cos x cos y plus sin x sin y? This is cos of x minus y. Is it clear? Okay. So what is alpha minus alpha by 2? Alpha by 2. You need not to go on taking LCM. It is 1 alpha, this is half alpha. 1 alpha minus half alpha is half alpha. This is cos alpha by 2. Let us come to here. I will take this term separately. What is alpha by 2 minus alpha? This is half alpha minus 1 alpha. So we get minus alpha by 2. Is that not? Is that clear? Half alpha minus alpha. So that becomes minus alpha by 2. What is sin of minus theta? Minus sin theta. So sin of minus alpha by 2 will become what? Minus sin alpha by 2. Denominator is cos alpha by 2. We have used this formula here. Sin of minus theta is minus sin theta. Okay. Here. What is alpha minus alpha by 2? Alpha by 2. So it becomes sin alpha by 2 upon cos alpha by 2. So alpha minus alpha by 2 is alpha by 2. So it is cos alpha by 2 divided by cos alpha by 2. Okay. So cos alpha by 2 and cos alpha by 2 cancels out. We get 1 minus sin alpha by 2 upon cos alpha by 2 is tan alpha by 2. Sin theta by cos theta is our tan theta. Sin alpha by 2 upon cos alpha by 2 is our tan alpha by 2. Cos 1. This is our simplified right hand side. I will call it as equation number 2. Already separately we have found out LHS. This is our LHS. Look at the elements present in LHS and RHS. Don't you think they are same? Isn't not? So finally we will write down the conclusion. From 1 and 2, we have shown that LHS is equal to RHS. Okay. So to solve this problem, you need to be familiar with all these formulae. Okay. So we'll consider the next problem. If A equals to we are given A matrix, prove that A cube minus 6A square plus 7A plus 2I equals to 0 matrix. Many a times this question has appeared in your annual examination, question of this particular type. Okay. See, again in this problem using A matrix we need to prove that LHS is equal to RHS. Look at the LHS. To find out left hand side, what I need to know first? I need to know A square matrix and A cube matrix. For that reason, first we shall find out A square matrix. How do we compute A square matrix? A into A matrix. Okay. So 1 0 2 0 2 1 2 0 3 into 1 0 2 0 2 1 2 0 3. Let us multiply these two matrices by using the row column multiplication concept. Many students commit mistake here. They multiply corresponding elements and write down the resultant matrix. It is not like that. When you multiply matrices, use row column multiplication concept. First row, first column to write down A11. So 1 into 1 1, 0 into 0 0, 2 2s are 4. Now first row, second column, 1 0s are 0, 0 2s are 0, 2 0s are 0. First row, third column, 1 2s are 2, 0 1s are 0, 2 3s are 6. Okay. Next, second row, first column, 0 1s are 0, 2 0s are 0, 1 2s are 2. Second row, second column, 0 into 0 0, 2 2s are 4, 1 0s are 0. Second row, third column, 0 2s are 0, 2 1s are 2, 3 1s are 3. Now, third row, first column, 2 1s are 2, 0, 3 2s are 6. Third row, second column, 2 into 0, 0, 0 2s are 0, 3 zeros are 0. Third row, third column, 2 2s are 4, 0 1s are 0, 3 3s are 9. So what do we get? This is 5, 0, 8, 2, 4, 5, 8, 0, 13. This is our A square matrix. Next, what I need to compute LHS? I need even A cube matrix. How do I write A cube matrix? A square into A matrix. Right? So already we people have found out A square matrix. I will use it here. here 508, 245, 8013 into A matrix 102021203. Multiply these two matrices. First row, first column, 5 ones are 5, 0 into 0, 0, 8 twos are 16. Okay. First row, second column, 5 zeros are 0, 0 twos are 0, 8 zeros are 0. First row, third column, 5 twos are 10, 0 ones are 0, 8 threes are 24. Second row, first column, 2 ones are 2, 0, 5 twos are 10. Second row, second column, 2 zeros are 0, 4 twos are 8, 5 zeros are 0. Second row, third column, 2 twos are 4, 2 twos are 4, 4 ones are 4, 5 threes are 15. Okay. So now, third row, first column, 8 ones are 8, 0 into 0, 0, 13 twos are 26. Second column, third row, second column, 8 zeros are 0, 0 twos are 0, 13 zeros are 0. Third row, third column, 8 twos are 16, 0 ones are 0, 13 threes are 13. Okay. So what is 5 plus 16? This is 21, 0, 34, 12, 8, 23, 34, 0, this is 55. This is our AQ matrix. Okay. Now I will take LHS. LHS is AQ minus 6A square plus 7A plus 2I. Okay. So in the place of AQ we have obtained the matrix 21, 0, 34, 12, 8, 23, 34, 0, 55. This is AQ minus 6 into A square 5, 0, 8, 2, 4, 5, 8, 0, 13 minus 6 A square plus 7 into A matrix 1, 0, 2, 0, 2, 1, 2, 0, 3, 7 into A matrix plus 2 into. So here we need to choose identity matrix of order 3 because we know that matrix addition and matrix subtraction is defined if matrices are of the same order. Even though he has not mentioned that you need to use I matrix of order 3, it's understood. Okay. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So we'll keep first matrix as it is. Minus Inside the second matrix, we need to multiply by 6. Scalar multiplication concept. 30, 6 zeros are 0. This is 48, 12, 24, 30, 48, 0, 13 6 are 78. Plus, multiply by 7 inside, 7 on the 7, 0, 14, 0, 14, 7, 14, 7 zeros are 0, 7 threes are 21, plus 2 ones are 0, 2 ones are 2, 0, 0, 0, 2, 0, 0, 0, 2. Okay. We are at the last step of the solution now. See. In between all these matrices, there is plus sign and minus sign. We are already familiar with addition and subtraction concept. When we add or subtract, we take the corresponding elements. We add them or subtract them. Okay. So it's plus 21. This is minus 30. Plus 7. Plus 2. 0. You are choosing corresponding elements. 0. 0. 0. This is plus 34, minus 48, plus 14, plus 0. Here plus 12, plus 12. This is minus 12, 0 plus 0. This is 8, minus 24, plus 14, plus 2. See, this is 8. Minus into plus, minus 24, plus 14, plus 2, 23, minus 30, plus 7, plus 0. Here it is 34, minus 48, plus 14, plus 0, 0, plus 0, plus 0, plus 0. This is 55. Minus 78 plus 21 plus 2. Now let us simplify each term. On simplification, first term will become what? 21 plus 7 plus 2, 30 minus 30 is 0. Second term is 0. 34 plus 14, 48 minus 48, 0. Thus when you go on simplifying each term, you get all the elements of the resultant matrix as 0. So this is nothing but our right hand side. So in the right hand side we wanted 0 matrix. So we have obtained 0 matrix. This is how we show that LHS is equal to RHS. Okay.